Welcome back to Homework Up with Miss Gore. Today we'll be talking about our Unit 6, Day 4 homework. So question one question one gives us a table that has an elapsed time with two different cars that are passing the 10, 20, 30, 40, and 50 meter mark on a test track. For car one, what is the average rate of change? And so they are asking me to find the change in distance divided by the change in time, which is also called my velocity. So my velocity, my formula I'll be using, is my delta D, change in distance, over my delta T, my change in time. So when I look at the 0 and the 10 mark, well, I don't have a 0 because at distance 0, my time would be 0. So my velocity would be my change in distance, which would be 10, over my time, and we're talking about car 1, so 4.472. So that is 10 meters, and we are going to consider this in seconds. And so my answer, my velocity, when I divide that, is 2.24 meters per second. Now between the 0 and the 50 mark. So again, the velocity is delta D over delta T. And when I plug my numbers in here, again, 0 to 50, so my difference has to be 50 meters. My 50 meter mark is 10 seconds, which would give me 5 meters per second. Now I'm looking at letter C, between the 20 and 30 mark. So again, same formula. V equals delta D over delta T. So my velocity, now this time I do have different values that I am plugging in, so between 20 and 30. So I'm going to start with subtracting 30 minus 20 over 7.746 minus 6.325, giving me a velocity of 7.04 meters per second. So letter D says, analyzing the data to describe the motion of car 1. Is it speeding up or is it slowing down? So looking at my velocities, I had 2.24 meters per second to 5 meters per second to 7 meters per second. So that is indeed speeding up. Okay, and I'd like you to now answer for part E for car 2. All right, skipping ahead, let's look at number 2. So number 2 says, decide whether you can match each table with either a linear function, an exponential function, or neither. So I'm going to take a look at number 1, and what I'm doing is I'm looking at my values. So noticing that my x's all go up by 1. Now I want to know, how do my y's change? Are they added to get from one term to another? Are they multiplied to get from one term to another? So I take a look at my pattern to go from each term to the next term. And I'm noticing to get from 4 to 6, I'm adding 2. 6 to 8, I'm adding 2, adding 2, adding 2, adding 2. So if I'm adding 2 each time, I know that this is a linear function. This is an arithmetic sequence. So in my linear function, I know that I have the form y equals mx plus b. So y equals, and I know that I'm changing by 2's, and now I want to look, what is my y-intercept? And there it is right there, so plus 8. Now let's take a look at number 2. So number 2, analyzing the same type of pattern. Do my x's go up by 1's? Yes, excellent. So now I'm looking, I go from 1/9 to 1/3, and 1/3 to 1 to 3 to 9 to 27. And I'm noticing that in order to do that, I am multiplying by 3 each time. And if I am multiplying, if I have a common multiplier, then I know that this is an exponential function. And since I have an exponential function with a common multiplier of 3, I know that my function equation is y equals 3 to the power of x. Okay, continuing on, let's talk about question 8. So question 8 gives me an f of x and then tells me to find f of 3x minus 8. So if I want to evaluate f of 3x minus 8, I'm going to plug that in for my x. So 4 minus 3x minus 8. So again, rewriting my input. So now I have 4 minus 3x plus an 8. So one more time, rewriting my input, I end up with negative 3x plus 12. And that is my function value for 3x minus 8. All right, hopefully that helped you with your homework, and I will see you again soon.